All right, welcome back.
Hi everybody, welcome back. We are ready for P5, which is
P5.
solving equations every which way under the sun,
All of
otherwise
them.
known as graphically, numerically, and algebraically. It's a lot of information, a lot of it you already know, so we are going to cram right through it as fast as we can here because we don't want you to watch a 45-minute video.
Yeah, neither do you. All right.
All right, a couple of key things to understanding when you're solving.
First, we're going to solve by graphing, okay? First thing you need to understand is that graphing answers have two possible places you can find answers in. They are...
Oh, two, sorry.
They
I'm
are
caught up.
two possible places. They'll either be where the two graphs intersect, if you want to graph a y1 and a y2, and calculate their intersection. Or if you want to graph y1 and set the whole equation equal to 0, it is the 0 or the x-intercepts, if you will. Okay?
So we're going to run through an example of each one of these. Now, we are assuming that you already know how to use a graphing calculator because this is pre-calculus.
And again, if you don't, you're going to come and get help.
You are.
All right, so first question. X cubed minus x equals 1. We're going to graph the left side as y1. So you're going to pull out your calculator, make y1 equal to x cubed minus x. And then you're going to make y2 the right side, which will be 1.
Okay.
And you're going to graph both of them. And we've done that for you, so if you want to take the moment to pause the video and graph it, there's your picture of what you should see.
Here's your y2. Here's your y1. Again, please pause if we're going way too fast.
Okay, where are the solutions going to be on this problem?
Okay, these solutions are going to be right here where the two things cross, where the curve and the line cross each other.
All right, so their intersections is the solution, and we're going to find that going calculate intersection, which is second trace and then number, what is like 5 or something like that.
Yep.
Okay, and we're going to go first curve, second curve, guess, and then we're going to get an answer of approximately 1.325 if we go to 3 decimal places.
Which we do all year long because this is pre-calculus.
And calculus requires 3 decimal places, so guess what pre-calculus requires?
3 decimal places.
3 all the time. All
Okay.
right, now let's do it another way. We're
Same
going to
question.
take this equation, same equation, we should get the same answer.
Right.
But now we're going to find it by finding the zeros, or where the thing crosses the x-axis. So what we're going to do first is set the equation equal to 0 by subtracting 1 from both sides. And then we're going to make y1 the left side, or the non-zero side, of our equation. And we're looking for where the y value is then 0, which is on the x-axis. Okay? So where are the solutions located? Right there on the x-axis. All right? And your calculator calls these zeros. We call them x-intercepts. And again, we find them exactly the same way. We have second calculate.
Not quite exactly, there's a different button.
Yeah, it's number 2 for
Calculate
0. Or 1 for 0, I don't know. But
now,
anyway.
keep in mind with both of these, whether it's an intersection or a 0, you have to actually see where they cross or see the x-intercept on your
correct.
screen for the calculator to be able to find it. If you can't see it, it can't find it.
Nope.
And it will give you
You got to
that
find the
error.
right window. So the same answer, if we calculate the 0, will be approximately 1.325.
I already forgot what it was.
And there we have it. Okay,
That's
again, if this doesn't make any sense and you've never done this before, please get in here and let's talk. Okay, we are assuming you've done this before.
All right, now some people like to solve numerically. That is, they like to look at the number values. Okay?
The only way you can create a table of numbers is just to make a big table, huh?
Yep, plug and chug. Your calculator will plug and chug for you. There's a table feature. Again, if you don't know how to use it, you're welcome to come and talk to us about it. But we've already created a table for you, and we want to know where is the answer. So what are we solving, Mr. Lecky?
Well, basically, if we're looking for a solution to an equation, what we're really asking is where this function equals 0. So if you notice the difference between the equation f of x equals negative x cubed plus x plus 1 and the statement that you put a box around, all we've changed is f of x has to be 0.
Correct.
So what we're looking for is really just a change in the signs of our f of x.
Okay.
So if we run down our list, we have positive, 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 and then we end up with a bunch of negatives.
So what must have happened between where the y value was positive and where the y value was negative?
It must have been 0 somewhere
It has
between.
to have been 0. We had
So-
to have crossed 0 right there.
How are we going to answer this question? Well, we're just going to say that our answer is somewhere between 1.3 and 1.4. And we can do that with words. We can do it with an inequality. We can even do it with interval notation if we wanted to. Okay? And that's all there is to it. So just look at the table, figure out where the signs are about to change, and that's where our answer is going to be. Exactly. Okay?
All right.
All right.
Algebraically.
Now for the fun part.
Okay, algebraically, when you learned it in Algebra 1, it's basically get the letter by itself, right? So we need to solve this thing. I'll run through it first, and then Mr. Lecky's got another way of thinking of it for you. Of course, we'd add 9 to both sides.
trying to isolate the y, so we're going to get rid of 9.
32.
That's good job there. All right. Then
We're going to divide by 2. Okay.
Now we need to get rid of the squared so that we get inside that parentheses, and we're going to do that by a square rooting both sides.
Okay.
And this is where, warning, warning, warning.
Warning!
You have to be careful. You're going to get 2y plus 3 on the left side
And you're
because
getting
it's
2x
going to
apparently.
cancel the, that's just a misspelling of y. All right. It's going to
2y.
cancel the squared, but the right side's going to give you a positive or negative 4. Don't forget the plus or minus. We got some things on the worksheets we're going to do in class to hopefully fill in why there's
Why
a plus
that's
or minus
happening.
there. The
But
square
when
root of
you're
16 is just 4, by the way. It's not 2 answers, it's just 4. But when you solve an equation, where you get positive
Yep.
or negative 4, okay? So we got 2 answers on the right side. We have to solve for y. You might want to go ahead and break it up like this and just go ahead and say 2y plus 3 equals 4 and 2y plus 3 equals negative 4, and that way you don't mess it up, okay? So we're going to subtract 3 from the left side and divide by 2, and you're going to subtract 3 from the right side and divide by 2 as well. And there's your 2 answers.
Ta-da.
Okay, and
Again,
if
you're
you're
solving.
wondering real quick, just a couple of little things here. When you had the order of operations, we had please excuse my dear Aunt Sally. And we were all really good at going through these, making sure we did parentheses first and all that fun stuff. When you solve equations, you undo operations. If there was addition, you subtract. If you're dividing, you multiply. So it should make sense to you that we undo the order as well when we're taking these things apart. So we're going to undo addition and subtraction first, which is why we added 9 to get rid of the minus 9 first. Then we undid the 2 because that was multiplying. Then before we could get into the parentheses, we had to get rid of the exponent, and then we could deal with what was in the parentheses. So if you're having trouble figuring out, once again, if you've never put all this together at some point in time in your life, you could just write down the order of operations and kind of remind yourself
Working
to go
backwards.
backwards so that you don't do things out of order. Because if you do things out of order solving, you get the wrong answer, just like when you do them out of order when you were simplifying.
When you're simplifying, exactly. And remember, the reason that we're videoing these things together is to give you more than one perspective. So use what you like, show us what you're doing, and we're happy. It's a big global thing here. You have to remember all your algebra all the time.
All the time.
All the time.
All right.
Okay, a little more algebra here, which you may or may not know.
Those of
but
you
this
coming
is,
straight from Algebra 2 last year, you did this quite a bit, I think.
you're really good at this. FST should have also done this, but we're going to complete the square, okay? So what that means is I have x squared plus 6x, and I am missing something right there to make a quantity squared.
Now there's
Okay.
another video, if you'd like to watch it, that will go through the process of completing the square. I will pop a link up on the screen. You can click on it.
Yep.
And
But for right now,
right
we're
now,
not going
we're
to take
just
the
going to
time.
go through the process of how to do it. And
So
if you
basically, we
have
need
never
half
seen it.
of 6, which is 3, and the number that's missing is that number squared, which is just a 9. So now, I've just unbalanced my equation. If I'm going to pop in a plus 9 there, I have to pop in a plus 9 here. What you do to one side, you have to do to the other. 7 and 9 is 16. Okay, now it looks a lot like what we just did on the last question. We're going to undo our squared, and we're going to get x plus 3 equals plus or minus 4.
don't forget that plus or minus.
Plus or minus gives us 2 equations. X plus 3 is 4, and it is negative 4. Okay? So we get a 1 and we get a negative 7. Again, these are solving equations. Go back and double check your answers. Plug them in and check them. Okay? Now, has letter B a little different from letter A, Mr. Lucky?
Letter B's got a number in front of x squared, and part of the completing the square process only works if the coefficient of x squared is a 1.
Ew, not a 1.
All right? And when it's not a 1, we make it a 1 by dividing everything in the problem, including the other side, by that coefficient. So we're going to divide everything in this problem by 2, and we're going to leave things as fractions if possible. 0 divided by 2 is 0. Now, on the last problem, we only wanted the x squared and the x term. This is the only process with x squareds that we don't set it equal to 0.
Yep.
Every other method of solving requires us to set it equal to 0. We're not going to do it here. We're going to set just the x squared, the x stuff on the left, and we're going to move everything else on the right side. And now again, we need to add something to both sides so that we have a perfect square on the left side. We're going to do that by taking half of 5 halves. Well, half times 5 halves is 5/4. That's the number going to go inside the parentheses.
Okay.
And then we're going to square that number, and that's what we're going to add to both sides. We're going to get 25/16, and we're going to add 25/16 to both sides. Now, The hard part is figuring out how to add 6 plus 25 sixteenths. But if you'll change it to fractions, 6 is just 96 over 16.
I know I'm on the wrong page.
6 times 16,
Yeah.
96. We are math teachers. We can multiply. Okay, so now we have 96 sixteenths plus 25 sixteenths, which makes 121 sixteenths.
I like that number.
All right. Why is that a nice number?
Because it's a perfect square.
It's always nice when it's a perfect square.
It's not always a perfect square, but in
It's
this
actually
scenario
not too
it
bad
is.
if it's not a perfect square, because that means you don't have to do much else with
Yeah,
it.
you don't have to simplify too much.
Okay, we take the square root of both sides just like we did last time. We get x plus 5/4 equals, don't forget the plus or minus, and the square root of 121 over 16 is just 11/4. So now we have two different problems here. X plus 5/4 equals 11/4. And we're going to subtract 5/4 from both the 11/4 and the negative 11/4. And if you don't have to break it up, you don't need to. But for most of you, you'll probably make fewer mistakes if you just write it as
Myself included.
two problems, okay?
This is going to give me 6/4.
6/4, which we
is
can
3
reduce to
halves.
3/2. And the other side's going to give us negative 16/4, which is simply negative 4.
There we go. So we get -4.
And there's our two
3/2.
answers
Okay.
using completing the square. If you want more again, we'll go ahead and click on that link from earlier.
And again, completing the square tends to be easier if the first number is 1. If it's not so bad. Just divide it. All right. Quadratic formula you should already know. So
In fact, let's go ahead and give them the quadratic formula one time because we're not going to do it again.
this is true.
Quadratic formula, what has to happen first? The ax squared plus bx plus c has to equal what?
0.
0. So if all that equals 0, then the answer is...
X equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a.
There's other songs on the internet if you need some help.
If those are better, sorry. I teach Algebra 1, so I just automatically sing it.
I don't sing. Okay.
But he does dance later in the year.
No. All right. So we're going to set this equal to 0. We're going to stop talking because we're going to run through this very quickly and speed up time. I would highly suggest you go ahead and pause it and make sure you did it right. Alrighty. Alright. I think that'll do it for quadratic formula. Just remember, it is an option. If you're not sure how to simplify that fraction completely and you didn't get 4 plus or minus the square root of 46 over 3, again, something that you should be really good at by now, but if you're having trouble, we're not opposed to helping you out. We're just not going to do it right now on a video.
Keep in mind these are the same answers. Okay, so whichever way you write it is fine with us.
Alrighty.
A little bit of factoring.
More factoring. Didn't we just factor?
We did just factor.
I feel like I did it about 15
But now we
minutes
are
ago.
solving by factoring.
Oh, all right.
Which means we need some actual answers.
So,
once again, to solve by factoring, to solve by quadratic formula, it has to equal 0. We cannot stress that enough. So on letter A, you're just going to minus your 3x over so that you get 7x squared minus 3x equals 0. First kind of factoring we want to check for is greatest common factor. So take out your x. We get x times 7x minus 3 equals 0. Now, here's the new part. This is called the zero product property. If two things are being multiplied and the answer is 0, take each of those two terms and set them equal to 0. So we've got green times yellow equals 0, so either green is 0 or yellow is 0. The first one's already solved for. Okay, the second one, you're going to add a 3 and divide by 7, and you're going to get x equals 3/7. Again, plug it in to check it. Okay, letter B, a little bit different. It equals 8x, so we're going to have to, again, make it equal to 0. 4x squared minus 8x plus 3 equals 0. And again, you can go ahead and do your box if you need to, but you're going to get 2x minus 1.
we're not going to go through this because we
just
just had a video on how to do this.
And 2x minus 3.
That we can't get it right, but hey.
And again, set each factor equal to 0. If 2x minus 1 equals 0 or 2x minus 3 equals 0, you're going to get your two answers. Either, oh, I was just going to tell me the answer. X is a half or x is 3/2. Way quicker than doing the quadratic formula if you don't have to.
I'm totally okay if they go from there to
I am absolutely okay. If you can look at 2x minus 1 and get x as a half, go for it. Okay? All right, so we have solved
by factoring,
by factoring.
quadratic formula,
Yes?
completing the square,
Yes.
extracting square roots,
Very good.
We have lots.
which are all algebraically.
And all quadratics, by the way.
Yeah, plus we've done numerically and we've done graphically.
Oh, I forgot about those.
Yeah, so we have one more thing we need to talk to you about, which you haven't done a whole lot, algebraically especially, which is absolute value.
What the heck is absolute value?
Okay, absolute value is a distance. It is a distance from 0. What do we know about distances?
Distances are always positive.
Distances are always positive. Okay, so if we have the absolute value of x equals 7, then I need the distance
This is the distance.
from 0.
X is from 0 is, as the equal sign, what?
7.
7. So if we have a number line, how many numbers are 7 spaces from 0? Not 6.
Well, I could go 7 to the right,
And we get to 7.
and I could go 7 to the left,
And we get,
-7.
awesome.
So
So
the absolute value of x equals 7, when we solve it,
what this means is that x equals 7
or
or
x equals -7.
x equals -7. And what it means for what we're about to do is what we took the inside and we said what was inside of there was either 7 or its opposite, -7.
Correct.
All
All right,
right.
let's do an example.
Let's try this. Now the key to doing this algebraically is to, again, treat the absolute value like a parentheses.
Absolutely.
And undo everything until we get the absolute value by itself.
And then we'll use our definition.
Absolutely.
Okay, so if we see a 2 times a parenthesis minus an 8, we're going to subtract an 8 first.
How about we add the 8?
Okay, add the 8.
All right.
He's so picky.
27.
And then we're going to divide by our 2.
Oh no. We got fractions again.
We do, 27 halves
Now that I have the absolute value by myself, I'm saying that the distance
is 27
from
halves.
0 is 27 halves. So that means that 3x plus 5 can equal -27 halves.
It could if we went to the left.
Or 3x plus 5 could equal
Positive
27 halves if we go to the right.
Okay, now we just got to keep going.
Simple problems
Subtract
to do
our
this.
5.
5 in terms of halves is really
Let's
10
do 10
halves. Is that
halves,
okay?
yeah.
So 3x is going to equal -37 halves. And if I divide by 3, that's really multiplying by 1/3. So that's -37 sixths. Or subtracting
Minus a
10
10.
halves would be 17 halves.
Yep.
Did you hear the droid? And divide by 3 or multiply by 1/3, we get 17 sixths.
They're probably all checking their phone. They thought it was theirs.
Alrighty. No cell phones in class.
Again, you can plug these back in and check them to make sure they both work.
Or
Now-
you can look at your answer key that you did earlier and make sure you did it right.
The other thing that's nice to double check, especially with absolute value, this is a little bit new for us, is to check it graphically.
So what would this look like? This would look
ABS.
like 2
ABS.
ABS
Oh yeah, there's a 2, I'm sorry.
parentheses 3x plus 5 and there was a
Minus
-8 and then you're going to make
And our
y2 equal to, was it 19? So that's what you're going to get when you graph both of those.
So the y1 is going to give you the v, and then the y2 is going to equal the 19. And again, we are looking for where these two things intersect each other. And
There's
it
our
happens
solutions.
twice.
And we've gone full circle.
Okay, so they're going to be -37/6 and 17/6.
Except for your calculator, give them to you as decimals.
It will. So you could just divide and double check.
Come talk to me later if you want to know how to turn that point from your calculator into that wonderful fraction. It's really easy. I'll show you later. Okay?
Have a great day.